A particle accelerates uniformly from rest. From rest, it means initial velocity equals 0 meter per second at 6.0 meter per second squared. It means the acceleration is 6 meter per second squared. Accelerates uniformly from rest at 6 meter per second. For 8 seconds, the time is 8 seconds. And then decelerates uniformly to rest. It means we have enough data. Decelerate, we don't know. To rest, what's the meaning of to rest? To rest means the final velocity is 0 meter per second. In the next 5 seconds, so the time here is 5 seconds. Now we are asked to determine the magnitude of the deceleration. Now let me explain to you. If you are driving the car and you start from rest, the car is at rest, it means 0 meter per second and is moving with a velocity. And at a particular time, we attained moving with acceleration 6.0 meter per second. It means that at a particular time, it has a velocity. That velocity now will now be the initial velocity, now coming to rest at 0 meter per second. At 0 meter per second. So in other words, all we just need to do is to calculate the velocity at this point. Now the velocity at this point will now become the initial velocity at this point. Alright, so what formula do we use? We use the first equation of motion, which says V equal U plus AT. Alright, so V equal 0 plus 6 times 8. V equal 48 meter per second. So at this point, it now becomes the initial velocity because it is coming to rest. We can't have 2v. Do you understand? So we're going to write the same equation plus AT. Now this has now become U, which is our initial velocity. And then it comes to rest at 0. So I'm going to write 0 equal 48 plus A times 5. So all I have now is 0 equal 48 plus 5A. 5A minus 5A equal 48. Divided by minus 5, divided by minus 5. So A equal 48 divided by minus 5 will give us minus 9.6 meter per second squared. Now let me explain this. The reason why we're having negative is because it is decelerating. Do you understand? So it means the acceleration, the negative of acceleration is deceleration. If you want to remove this negative sign, then you need to tell us that the deceleration equal 9.6 meter per second. We are saying the deceleration equal 9.6 meter per second. The acceleration equal minus 9.6. It's as simple as that. So the negative value of acceleration is actually deceleration. That's all concerning question 4. Now let's go to question 5. And I want you to pay attention to question 5. Now, starting from rest, it's very, very simple. All we just need to do is write our value. U equal 0 meter per second. Starting from rest, a Formula 1 car accelerates uniformly at 65 meter. Is it 65? I think it's 25. I wrote. Sorry. 25 meter per second I'll write my acceleration to be 25 meters per second squared. For 30 seconds, the time is 30 seconds. Now the question is, what is the distance covered in the last 1 second? Now, let me explain this. When you see a question like this, saying in the last 1 second, it means the time is two values. The time is 30 seconds and the time is 29 seconds. In the last 1 second, the total time is 30 seconds. If a person, if it takes 10 seconds, the total time is 10 seconds, and your heart in the last 1 second, so the time we'll be using will be 10 and 9. If the total time is, let's say, 49 seconds, and your heart in the last 1 second, we'll be using two times, 48 and 49 seconds. It's as simple as that. So it means in the last 1 second, it means we are going to find, we're looking for the distance, S, we'll find distance at the 30th seconds, then we'll find the distance at the 29 seconds, and then we'll find the difference. It's as simple as that. You find the distance in the 30th second, you find the distance in the 29 seconds, and then you find the difference. Okay, so what is the formula? S equal UT plus RAT squared. So at S30, U is 0. So everything here is gone. So what I have is 1/2 times 25 times 30 squared. So S30 equal, what I have here is 1/2 times 25 times 900. This and this will give me 450. Now 25 times 450 is 11,250 meters. So I'm going to look for the distance in the 29 seconds. It's the same thing, 1/2 times 25 times 29 squared, which will give you 1/2 times 25 times 29 squared. Let me just punch the calculator for everything. S29, let me just punch the calculator for everything. It will give me 10,512.5 meters. Then I will now find the difference. So now S30 minus S29 equal 1,250 minus 10,512.5. Now I will find the difference. And this is 4, this is 9, this is 10, this is 5, this is 7, this is 3, 0, 2, and this is 7 meters. So this is the distance in the last 1 second. Now the second one is in the 17th second. So we're going to have 2 times. Can you guess? Alright. You're going to have 16 and then you're going to have 17. You find the time in the 17th second, you find the time in the 16th second, and find the difference. If the question has in the 5th second of motion, you find the distance in the 5th where time equal 5 and when time equal 4, and then you're going to find the difference. If they ask you in the 6th second, can you tell me the answer? Oh, that's correct. You put time as 6, you put time as 5, and then you find the difference. So let's do that. In the 17th second, it means at the 17th second, we look for S17 minus S16. Now I used a very long process here. I'm going to make it shorter by saying S equal UT plus RAT squared. UT is cancelled because initial velocity is 0. Alright? So S17 minus S16 equal 1 over 2 AT at 17 seconds minus 1 over 2 AT at 16 seconds. What is common here is 1 over 2A, so I will factorize that out. I'll be left with T17 squared minus T16 squared. So this equal 1 over 2 times, this is 25. Alright, at the 17 seconds minus the 16 seconds. So this is 1 over 2 times 25. 17 squared is 289 minus 16 squared is 256. Alright, so when I punch my calculator for everything, S equal 412.5 meter. So this is how to solve this question. If this is complex, you can just follow this method and follow it step by step. So the last question in this segment. Alright. Let's go. An object falls freely from a height of 25 meter. Height 25 meter. Okay? Onto the roof of a building 5 meter. Okay, let's continue reading. 5 meter high. Calculate the velocity with which the object strikes the roof. Oh, so it's falling from a height of 25 meter. The building is 5 meter high. So it means our total will be the height minus the building, because the object is falling on the roof of the building. You get it? It's falling like this, and this is the building, and this is 5 meter. This is 25 meter. So the distance, because it's going to the landing gear, will be 25 minus 5, which will give me 20 meter. So our height is 20 meter. Okay, we have to calculate the velocity. We don't know the velocity. Now, an object falls freely. I'm sorry, I skipped that. When an object is falling freely, that is downward motion. And when we're talking about downward motion, it means it is moving with gravity. And that means our initial velocity equals 0 meter per second. If an object is going upwardly, moving against gravity, it means V equals 0 meter per second. Just like a car starting from rest, U equals 0 meter per second. A car comes to rest, V equals 0 meter per second. Okay, so what formula will fit in this? We have 3, right? So let's see which will fit, which will fit. Okay, the third, V squared equal U squared plus 2G H, where G is acceleration due to gravity. It's a constant. So this is V squared equals 0 squared plus 2 times 10 times 20. So V squared equal 400. I take the square root of both sides. Square root cancel square. V equal 20 meter per second. So that's how to solve this question. See you at the next 3 questions. That's question 7, question 8, question 9. Thank you.